Hi all. So I'm Divya. I'm working as an assistant professor at the Department of Biomedical Engineering at Sri Shanmuga College of Engineering and Technology. Today, I would like to present the topic mesh analysis. So before getting into the topic, we need to know what is the use of mesh analysis, where we apply it, right? So if you want to find out a response of a particular circuit, that is the current flowing to the circuit or voltage across the circuit, that is current flowing across a branch or particular element or voltage across a branch or particular element, we need to apply the mesh analysis there. Let me show you how. So before getting to the topic, we need to know some of the basics like Ohm's law and Kirchhoff's law. So what is Ohm's law? The statement of Ohm's law is at constant temperature, voltage across a particular element is directly proportional to the current flowing through the element. So here we can see the Ohm's law triangle. Here voltage across an element is directly proportional to the current flowing through circuit. That is V is equal to I, right? V is equal to I. V is directly proportional to I. So to remove the proportionality, you have to include the constant R. So R is nothing but the resistance. So we can write this equation in two another forms. We can write the equation V is equal to IR in two another forms. That is I is equal to V divided by R. I is equal to V divided by R. R equal to V divided by I. R is equal to V divided by I. So we can write as V is equal to I into R. I is equal to V divided by R. R is equal to V divided by I. So we can keep remind of these things with the help of this Ohm's law triangle. Okay, next, what is Kirchhoff's law? Here we have two laws in Kirchhoff's law. The first one is Kirchhoff's voltage law. We'll use Kirchhoff's voltage law only in the mesh analysis. So what is Kirchhoff's voltage law? So what is Kirchhoff's law? Kirchhoff's voltage law is sum of potential drop is equal to sum of potential rise. That is, in a closed circuit, the sum of potential drops and which will be equal to the sum of potential drop. Around a closed path, the voltage will be equal to 0. Mesh analysis is otherwise called as loop analysis. Mesh analysis is otherwise called as loop analysis. First, we need to know what is the difference between mesh and a loop, right? So mesh is a closed path. Loop is also a closed path. So mesh is a closed path which should not contain any other closed path inside it. Loop is a closed path which can contain closed path inside it. So look at the circuit here. So here we can see the circuit A. We can see the closed path A, B, G, H, right? It is a closed path. Then you can see the closed path A, B, C, F, G, H. It is also a closed path, right? So what is the difference between these two? A, B, G, H is a closed path which does not contain any closed path inside it, right? But what about the case A, B, C, F, GH, it have a closed path, it have another closed path AB GH inside it, right? So ABGH is a mesh, and but ABCFGH is a loop. ABGH is also called a loop. We can call it as a loop or mesh. but we cannot call A, B, C, F, G, H is a mesh. We can call it as a loop. I think you can understand the difference between mesh and loop now. So in formulating mesh analysis, we have to assign the mesh current for each mesh. We have to formulate the mesh current for each mesh. So you can look here. There are mesh currents I1, I2, I3 have been assigned. So this is a assumption. We have to assign by ourselves. If the in the given circuit, if they given the mesh current or the direction, we have to use it. Otherwise, we have to make the mesh current by ourselves. We have to make it either clockwise or anti-clockwise. So if you make it as a clockwise for all the meshes, it will be easy for solving the problems. So mesh currents are short of fictitious one. That is, it is a sort of assumption. So in that, a particular mesh current does not define current in each branch of the mesh to which it is assigned. First, we need to find out the mesh currents. So with the help of mesh current, we can find out the separate branch current or branch current across the particular element. Here we can find out a circuit which illustrating the mesh analysis. So here we have two meshes. So that can be find by, okay. So you can mark, I'm marking here as A, B, C, D, E, F. Okay, here you can consider this one as a mesh 1, right? So here the current flowing through mesh 1 is I1. So here you have to apply the Kirchhoff's voltage law. So what is Kirchhoff's voltage law? Sum of potential drop is equal to sum of potential rise. So potential across a voltage source can be considered as a potential rise. Okay, so you have to write in one side of the equation, and voltage across the potential across an resistance can be considered as a voltage drop. So sum of voltage drop can be written in the another side of the equation. So here we can find only one voltage source, right? So voltage across a voltage source VA should be written in one side of the equation, and another side of the equation we have two resistances. Voltage across R1 is V1 plus voltage across this Rx is VL1. Okay, so where how can we find out voltage across V1 by applying Ohm's law? V is equal to I into R, right? V is equal to I into R. So voltage across this R1 is V1 is equal to I1 into R1. Voltage across this VL1 is I1 minus I2 into Rx. So here you can write this as I1 R1. V1 is I1 R1 plus VL1 is I1 minus I2 into Rx, which is equal to VA. So this can be written as, by simplifying this equation, this can be written as R1 plus Rx into I1 minus Rx into I2 is equal to VA. So this is the equation number 1. And now you can look at the second mesh. You can look at the second mesh. Here in the same manner, you have to apply the Kirchhoff's voltage law. The current flowing in the second mesh is I2. Here we are having a voltage source. So look at the direction of current flowing through the voltage source. So the direction of current is flowing towards negative terminal, right? So the direction of the mesh current is flowing towards the negative terminal. So you have to write as minus VB. So VL1 potential rise should be written in the one side of the equation, right? So potential rise is the voltage across the voltage source can be written in the one side of the equation, that is minus VB, and potential drop across the another potential drop across the resistors can be written in the another side of the equation, VL1 plus V2. Okay, so how can you find out VL1? By applying Ohm's law, that is the current flowing across the resistance Rx is I2 minus I1, I2 minus I1. Here you are writing equation for the second mesh, you have to write as I2 minus I1 into Rx. And what is the voltage across resistance R2? V2 is equal to I2 into R2. Now substituting equation 3 in equation 2, you can get the equation as I2 minus I1 into Rx plus I2 into R2, which is equal to minus VB. So this can be simplified like minus Rx plus Rx into I1 plus Rx plus R2 into I2 is equal to minus VB. So this is equation number 4. And now we have found out the two linear equations. So with the help of, by solving these two linear equations, you can find out the miscurrents I1 and I2. So after finding miscurrents I1 and I2, you can find out the values of current flowing through a particular resistance or voltage across the particular resistance. So thank you.